Question 1. Vertical reflection of a logarithmic function. How to tackle it? Firstly, understand vertical reflection. A vertical reflection over the x-axis involves multiplying the function by -1. For example, function x equals to log base b of x becomes negative log base b f of x. Secondly, domain. This stays the same because reflection over the x-axis doesn't affect the x values. Thirdly, range. The range changes from -infinity to +infinity to the same set, but now all the output values, y values flip sign, visually show how the graph flips upside down. Firstly, diagram. Sketch both log base b of x and negative log base b of x on the same set of axes to clearly show the reflection. Script for question 2. Horizontal and vertical translation of a logarithmic function. Next, we will talk about how the domain and range change when we apply horizontal and vertical translations to a logarithmic function. Suppose we start with function x equals to log base b of x and then transform it into function x equals to log base b of x minus h 8k. The horizontal translation happens when we replace x with x minus h. This moves the graph right by h units if h is positive. The domain is affected here. Originally, the domain was x greater than 0, but now it becomes x greater than h, because the log function must always have a positive argument. Firstly, graph the line y equals to x on the same grid. The line y equals to x is a diagonal line that goes through the orange at a 45-degree angle. It's important because when we reflect a function over the line, we got its inverse. So we will draw this line as a reference line on our graph. Secondly, graph the inverse function x by reflecting function x across the line y equals to x. To graph the inverse function, we take each point on the graph of function x and reflect it over the line y equals to x. That means we switch the x and y coordinates of each point. For example, if a point on function x is 2 to -3, then the corresponding point on inverse function x is -3 to 2. This reflection gives us the shape of the inverse graph. Thirdly, determine the domain, range, and asymptote of inverse function x. Let's analyze the original function first. The domain of function x is all x greater than 0, because we can only take the logarithm of positive numbers. The range is all real numbers because a logarithmic function can output any real value. The vertical asymptote of function x is at x equals to 0, where the log is undefined. Now for the inverse. The domain of the inverse function x is the range of the original, which is all real numbers, -infinity to +infinity. The range of inverse function x is domain of the original, 0 to +infinity. The asymptote flips from vertical to horizontal since the original. The asymptote flips from vertical to horizontal since the original asymptote was x equals to 0. The inverse has a horizontal asymptote at y equals to 0. Question 3. Step 1. Solve x and y. X equals to a half log base 10 of y minus 4. Step 2. Solve for y. Add 4 to both sides. x 8 4 equals to a half log base 10 of y. Multiply both sides by 2. 2x is 4 equals to log base 10 of y. Convert from logarithmic form to expressional form.